Welcome friends to this series of learning Google Cloud Platform. In this lecture, we will make a three-tier web application more secure as well as resilient, highly available, robust by putting them behind a load balancer. So are you excited to have this experienced? I'm sure you'll be delighted to have this learning. If you have not yet subscribed to this channel, please do it now. This will help you to watch when the new videos will be available. Also, please hit the notification button so that you can get notified too. Friends, in an earlier lecture, we created a three-tier web application by separating web from the app server and securing app server and the database server by restricting their access from the outside world with the help of VPC networking and the firewall rules. If you missed that video, you can watch it. We are providing the link in the description below. So in this lecture, we will create a managed instance groups for both app and the web servers. This will increase our system's availability and thus our application will be more resilient and highly available. Also, we will keep an internal load balancer in front of our app server so that app server will be within the private network and will be more secure to the load balancer, which can filter malicious connections out. Apart from that, we will keep one global external load balancer. This is the HTTP load balancer in front of our web server in a MIG. This will protect our web servers from the external threat and will help to hide the web server behind it. Also, we will have a common IP to interact with our application. We will completely not bother about the VM instance's health. Doesn't matter whether the VM instance or crashed spot instances are taken away. Our application will be up and running all the time. So let's get started.
Welcome, friends. This is our Google Cloud Web Console. So, in the last lecture, we created this app on different VMs we spread across the database, web, and app servers. So, app server and database servers are behind the public zone, so they are private and they have no external IP assigned. If you see the web server, uh, so it is having the external IP and it is exposed to the world. And if we go to this browser and hit the public IP of the web server, our web page is being served. So, though our database and app servers are private, our web server can still serve the application as expectation. Now, in this lecture, we are going to resiliate and provide the high availability over there. So just notice that each of these servers are micro spot VM instances. Now, for any reason this app server crashes or app server does not solve the application for any reason due to the zonal failure or disaster situation or anything like that, the web server cannot able to solve the request. So in order to do that, what we are going to do, we will create the managed instance groups for web server and the app server, and we will put the load balancer in front of them so that doesn't matter what happens to the zone, doesn't matter what happens to this VM, our application will live all the time. So let's get started. So first and foremost thing, you can remember that we removed the SSH from this app server. Now we are going to copy the applications to our Google Cloud storage so that we can reuse that application. So for a temporary basis, we are going to edit these and we are going to allow the SSH port for this particular instance. So let's edit this one and let's provide the allow SSH back and let's save this one. So our app server can be accessed through our Cloud Shell now, as we have opened the SSH port. So maybe we can say G Cloud Compute Instances List and then G Cloud Compute SSH, and we can say app server, and zone is US Central 1. See, so let's connect to the app server. Okay, so now let's go to this IAM and admin, where we are going to create one service account. We will use this service account to authenticate the GCS bucket, and we will upload our app content. So let's create it quickly. We are going to name this as GCS key, and we can provide some grants. So, for example, we can say storage admin. So, what storage admin will do, it will provide the full control of the buckets and objects. So, we are going to provide the storage admin to this service account key. And once it is done, we are going to generate a JSON service key upon going there, and we can add one key. So, this particular JSON file will be downloaded at my local. So what we will do, we can go to this Cloud Shell. We can say y gcs key.json,
and paste the content. So, and now we can authenticate with this key, uh, GCS key.json, so that we can use the service account key for storage. And now we can able to access our Google Cloud storage. Go to their app directory, and maybe we can tar the file for this entire my app directory. Okay, so let's to the parent directory, and we can see this my app is there. So what we will do, we will tar these directories, so tar minus cf and my app dot char and my app. We will start starting this particular file, and you can see this my app dot tar is there, so we can further compress this my dot tar, and obviously we need to provide the 0, and it is tar. So the next thing we will do, we will upload this file. So again, I'm just going to check the location. So I created this bucket over there. So maybe we can use the same bucket. So you can say miter dot zip to be uploaded over here. So it is uploaded. So let's go to this cloud storage bucket. And as we created this bucket earlier, so yeah, so we got this over there. Okay, so now we will use this star file for our application instance template. Okay, now let's go to this template, and let's create a template for app server. So we can give a name like app server, and let it make it a regional one, and app server is in central US central one, and we can keep our favorite micro one, spot VM, and we need a Ubuntu system, it's okay, and then in the advanced option, in the networking. So here we are going to provide this allow Python app port. So in the earlier lecture, we created this firewall rule, and we're going to attach these tags into this app server. So the next thing we're going to do, we need to change this to US Asia, and definitely the subnet would be US Central GA, and we don't need the external IP. And in the management stuff, in the automation script, what exactly we need to do? We need to provide all the stuff that we have done. So here, what we are going to do, we are first update the OS, and then we're going to install the Python script and the libraries for MySQL client. We are going to install the Flask, and then the virtual environment, and then we are going to copy the entire application from Google's cloud storage. This is what we just uploaded few minutes back, and then uncompressing it in a /my app, and then we're going to create a virtual environment, and then we're going to run these in VM instance. So basically, we are automating all these things. Once the VM will be created, it will start doing all these things. So what exactly we did? We created this app server in US Central 1. We attached the allow Python app port. We are creating a Ubuntu server, and in US Asia VPC under US Central GA subnetwork, and we are not providing any external IP address. So this is what the template is actually created for. And once the template will be created, we will use the template for creating the MIG. Okay, so the instance template is ready. Now let's go to these instance groups, and let us create the first instance group for the app server. And we are going to use this app server template, and we can span it across multiple zones for having the better availability. And then we are going to say that we can, for example, the maximum 2 number of instances when the CPU will be around 90%, and that's it. And we don't need any auto scaling schedule. Initializing period, we are fine. Maybe we can keep it as 300, and then scaling control, we don't need instance repair and auto healing. Here we need to create a health check. App server check, and this health check we can say regional, because all our app servers will be in US Central 1 region, and this would be 5,000 port, and we can say health check interval maybe 300 in every 5 minutes. Health check will be checked, and maybe um, unhealthy in these consecutive 5 failures, because it will take a lot of time to install the Python app and um, install it in the VM instance. And we can say after the instance configuration, if there is any instance which we have done and there is no standby pool we are going to create, let's click the create button. So let it create. Once it will be done, I'll be back. Let me pause my video till then. Okay, so our MIG is ready. But if you go to this MIG, you can see the health check is saying that 0% instance is healthy, but the instance was created. So the problem is that if you go to this Google document and go to this site, you can find you need to provide the health check probe IP to access your port 5000 in our case. So our health check is basically being solved from this particular IP. So this particular IP range should get this 5000 port open. So in our case, we can go to our firewall rule and we can go to our allow Python app port firewall rule and we can edit that one. So this is our allow Python app and we can edit this rule. And apart from this IP range for the television, let us provide this IP range as well for this health check so that health check can reach this VM instance and can check whether this is healthy or not. So let's save this firewall rule. Okay, and also we need to create the NAT gateway because this VM instances in US Central GA does not have the access over the internet. So only we are having the access, the databases in the DB private GA subnet. So as we are going to install the Python and all the applications from internet, we need this NAT gateway and we can name this NAT gateway as app NAT gateway, and we will provide this public access to US Central 1 region, and we can say the cloud writer, and maybe we can custom this one as US Central GA, and we can say this is the range for all the app servers. So we can select this one and okay, and that's it. We can say create. So once it is created, all the VM instances in the app template will able to use the internet. But from the internet user, any user from the internet will not able to access these VM instances in the app MIG. Okay. See, after waiting for a couple of minutes, we can see this app server MIG is completely okay and it is up and running. Okay. So, and 100% of the VMs are healthy in state. So they are actually serving the application. Now, next thing we need to do, we need to create a load balancer in front of it. So let's go here and click this load balancing. And what we will do, we will create a load balancer in front of our app server. So now it's an application load balancer. See, only between the VMs, we are going to create this load balancer because app servers are within our private networks. It is not going to be exposed in internet. Now, it should be cross region because our app servers are in US Central 1 region and our web servers will be on Delhi Asia region. So it is a cross region internal application load balancer that is going to be created. Now, we need to provide some name like app load balancer, and the network should be US Asia. Okay, and it is HTTP protocol and sub network region. We can say US Central 1, and we need to reserve some IP. This range of this IP, okay, the subnet proxy that is going to be created, the VMs should able to access this app server in 5000 port. So whatever the IP range you are going to put over here, that IP range should access the port 5000. Okay. Now let's give some name and add. Now what we will go to do, we will open the firewall allow Python app port for this IP range as well. So it's creating the subnet, and you need to choose the subnetwork as US Central GA, and the port is 5000. And before doing that, let us go to these allow Python app port firewall rules, and let's edit it and give the range of the subnet. Okay, and save it. And then let's create these front end, and on the back end, we are going to create one back end. Let's give some name, app load balancer front end, and backend type is instance group, backend is app servers, and port number is 5000. We are fine with this utilization and done. In advanced configuration, we are not going to change anything. So it's basically US Central 1 5000 port, and the health check we need to create. Now this health check is basically cross region health check. So we will give some name for the cross region health check. App load balancer cross region health check, because the earlier health check will not work because those are very much region specific, and this health check should be 5000 port, and here we can say 300 seconds interval, and timeout will be considered as well, and healthy threshold consecutive success is 2 is fine. Unhealthy, maybe we can say 5 unhealthy. So after 5 consecutive unhealthy requests, it will be considered as a unhealthy one, and let's create. And then we're going to create this app load balancer. Let it create. I'll be back on this slide. Load balancer is created, and one backend service is completely active. Okay. So now what we are going to do, we are going to grab this IP address of this internal load balancer, and we will use this IP address in our template for web server. So now we're going to create one web server instance template. Let's create this template for the web server. Now we can name it web server, And again, it is going to be a regional one, but this should be for Delhi region because our web server will be in Delhi. So next, we can keep it as P2 micro and spot instance. So it doesn't matter whether this spot instance will be taken away. Our MIG will create a new spot instance instantaneously without having any issue. So we are fine with this Debian image. Now networking, and we can say the port is allow HTTP because we are allowing external world to communicate, so that we are allowing the internet user to send the HTTP request to these VM instances. Now let's change the network to Delhi subnet GA, and we need the external IP and say done. And in this automation script, now we are going to install the Nginx, and we are going to configure the Nginx as well. What we need to do, we need to grab this IP address of the load balancer, and we will use the load balancer IP address over here. So what it is going to do, it will actually install the Nginx, and then it is declaring the upstream as a load balancer as the upstream, and then it is configuring the Nginx, which is basically under etc Nginx site available my app, and it is going to update this configuration HTTP version 1.1. Whenever the port will be listened at 80, it will actually redirect this to HTTP and then this load balancer in US Central 1 region. So I have explained all these things in the earlier lecture, the last lecture. If you have not yet watched that video, I would recommend to watch that video first for getting more clarification of this automation script. Now, we are done with configuring this template, and let's create the template. Okay, our web server instance template is ready. So let's create the instance group. So we can name the instance group as web server, and definitely the web server template is being used. We can choose the multiple zones for the higher availability, and we can say maximum two number of instances will be scaled out, and CPU utilization is 60%. It's fine. And initializing period, maybe we can say 3 minutes, and we don't need the scaling control for the instance repair, as well as we can auto healing. We need to create a health check. We can keep some name like web server health check, and it can be regional, and it should be in Delhi region. And port is 80. That's absolutely right. Health check interval again, we can say 300 and say 300, and unhealthy is consecutive 5 failures. It will mark as unhealthy, and that's it. We can say save. And now auto healing delay, we can say 300, or maybe we can say 600 for 10 minutes. Update the instance configuration once it will be repaired. Let's create this MIT. Okay, the MIG is ready. Let's go inside the MIG, waiting for the instance to be verified. So let's wait for some time. Please verify the instance. Okay, so you can see this MIG is healthy. So now let's create a load balancer in front of it. So we can say create load balancer. It should be a global load balancer and it should be from internet to this VM. So we can say continue and we can give some name, web load balancer. We can say the name as web load balancer from 10 and it should be HTTP 8480 is fine. So backend, you can give some name like web load balancer backend, and we say the instance it is web server, and it is HTTP protocol. Everything looks good, and you can say port number definitely 80. Also, we need to provide the health check. We can check that. We can provide some security policy, maybe we can say web server backend security policy. Yeah. And let's create this global load balancer. Okay, our application load balancer and the web load balancer both are created and looks healthy. So our web load balancer is created and we can see the IP address and the port is assigned. So maybe we can grab this IP address. So maybe we can give this browser web address and bang on. So our web application is actually solving the request from this app server behind it. So right now, it doesn't matter whether our zone gets failed or the zone gets crashed or the VMs get crashed as its spot instances, they may taken away or anything bad can happen. Our application will be available up and running. So, thank you friends for watching this video. We from the Learning Life team congratulate you on completing this video. In this lecture, we created a three-tier web application by separating web server from the app server. And also we created them as a production like. We made the three-tier web application a resilient one as well as highly available, robust one by putting them behind the load balancer and also secured them from the external threats. Wish you all the best and good luck. Before leaving here, please do not forget to like this video and subscribe to this channel. We worked a lot to present you with such a beautiful thing. So please encourage us by putting your comments in the comment section. If you have any doubt, please leave your comments and we will reply with our best efforts. Have a nice day and see you in the next lecture.